So this video is about refracting telescopes. To make a refracting telescope you need two lenses, and the two lenses that you need are a weak lens at the front of the telescope and the back of the telescope a much stronger lens. And by weak and strong I'm referring to the power of the lens. So the weak lens at the front is known as the objective lens, and if you think it's near the object, so that's why it's the objective lens. And the stronger lens here is the eyepiece lens, because that is where you put your eye. So now the role of the weak lens is to bring light to a focus, and the role of the strong eyepiece lens is simply to magnify that image. So the eyepiece lens acts as a magnifying glass, and the weak objective lens at the front acts to bring the rays together. So this one brings the light to a focus, and this one acts as a magnifying glass. In order to make the image much bigger. So if we imagine we've got rays coming in from a distant object, like so, then the refracting lens is going to bring, let's draw the principal axis in as well. So there is the principal axis, and those three rays are going to be brought to a focus somewhere about here. Let's just draw those in. Like so, and those rays will carry on in those directions. I haven't drawn my objective lens big enough, classy. Draw that a bit larger to take that into account. And as they reach there, they will then be reflected towards the eye. So, and so this is the focal point of this lens. Then the magnifying glass effect will magnify those rays into the eye, and then if you extend these rays backwards, these will eventually meet at infinity, and so it looks like, from your eye's perspective, that you're looking at the object that you focused on at infinity. The refracting telescope works to magnify the image, and the magnification of a telescope is related to the focal length of the two lenses. So the magnification is equal to the focal length of the objective lens divided by the focal length of the eyepiece lens. Now, because when you're doing this calculation, these will both have the same unit, so this will be in meters and this will be in meters, so the units will cancel each other out. So ultimately what you get is a ratio or a multiplication factor. So this could be how many times nearer it might appear, or increasing what we call the angular magnification, so the angle it casts from the sky. So if we have, for example, in our telescope, if we have focal length of the objective lens is 0.5 meters, and the focal length of the eyepiece lens is 0.05 meters or 5 centimeters, then the magnification will be 0.5 divided by 0.05 equals 10. So the magnification is 10. There are no units, and what the 10 means is either it looks like it's 10 times closer. Or you can think of it as increasing the angular size by 10 times. Now if you're looking at a very distant star, then the distant star is a tiny point of light, so it won't appear any bigger. 10 times not very big, it's still not very big. But it will increase the separation of two stars that are close together. So for example, if two stars appear very close together, then through the telescope they will appear much further apart, so you'll be able to resolve the difference between the two. Common calculations asked with this also relate to the power of the lens. Because the power of the lens is 1 over the focal length, then you can calculate the magnification using the powers of the lenses.